This is the walkthrough of question 1 from the F322 paper done in May 2012. The first question is about crude oil, and you have to explain why crude oil can be separated into fractions. So this is about explaining the reason for why crude oil can be separated by this particular method, fractional distillation, and that works because different molecules have different boiling points. To make sure we cover everything on the mark scheme though, we say these molecules have a different size, MR, mass, different number of electrons, something like that, to indicate why they have different boiling points. The use of biofuels such as biodiesel or bioethanol rather than petrol or diesel is about a number of factors. So crude oil is non-renewable, it's running out, so we can save crude oil by using biodiesel or bioethanol, and also because biodiesel and bioethanol absorb CO2 when the plants that produce them are growing during their photosynthesis, then the amount of CO2 put into the atmosphere by biofuels is less. Part C is about the cracking of crude oil, in particular this fraction C12H26. So when we do crack C12H26 we get a variety of alkanes and alkenes with different chain lengths. Now the reason we get different lengths of chain is because different carbon-carbon bonds in the C12 molecule can be broken during cracking. So it's due to breaking of different carbon-carbon bonds within the large molecule. Part 2 is about one of the products of cracking C12H26, and we're calling that product alkene A. Now, as well as alkene A, we're forming one molecule of propane, C3H8. So you can see down here I've started an equation where I'm trying to figure out from C12H26 if we're making one of our products, propane. It will help if we knock off those 3 carbons and those 8 hydrogens from C12H26 to think about what might be our alkene A. And it says several molecules of alkene A, a single alkene. Well, we're left with 9 carbons, so 12 minus 3 is 9, and 18 hydrogens because 26 minus 8 is 18. The C9H18 is going to give us 3 molecules of C3H6 being alkenes. So we've really already identified alkene A. We've got to be able to give reasons though, and we can use the other questions to show that really. So in a mass spectrum we've got some peaks at 15, 27 and 42, and there are no MZ values above 42, and that tells us that this must be the molecular ion peak, and so the MR of our alkene must be 42, and if we add up 3 carbons and 6 hydrogens, the molecular ion peak would indeed have a mass of 42, so that's some evidence to suggest that our alkene is propene. Now, because we've been given the mass to charge ratios of some other fragments of this mass spectrum, we should really talk about what they might represent, and we're actually specifically asked about the one at 27 here. So if we fragment by breaking this carbon-carbon bond here, we're actually going to remove this CH3. What we're left with is 2 carbons, which add up to an MR of 24, and 3 hydrogens, which gives a total MR of 27. So the fragment responsible for the M to Z value peak at 27 is CH2, CH plus. Very important that we get CH2, CH2 plus at 27. Now, when we break this bond here, the other possible fragment is a CH3 plus, and that's the fragment responsible for the peak at M to Z 15. So that's another possibility to score a mark here in the explanation part. The equation now we should easily be able to see our balanced equation making 1 propane and 3 ethenes. Part D is one of those questions that looks very unstructured. We've got lots of space to write the answer, and it's very difficult for us when we're inexperienced to really decide what the examiner wants us to write about. So I would recommend breaking this down. We've got to describe how ethene could be converted into 1,2-dibromoethane. That could be question 1. How you can convert ethene into bromoethane. That could be question 2. And how we convert ethene into ethanol. That could be question 3. And then question 4, we've got to name and describe the mechanism for making dibromoethane. Okay, so if we imagine that this is the answer to question 1, this breaks down and structures this question a little bit more. It's very easy to get sucked into thinking we've got to write a lot for each of these. But if we think about the number of marks available, really, we're probably just going to get 1 mark for describing how ethene can be made into 1,2-dibromoethane. So we simply need to say that we add bromine, or an equation is an alternative way to score that first mark. Similarly, to make bromoethane, we need to add HBr. Okay, so this is bromoethane, and again, an equation or just a statement would be enough to get that second mark for showing how we make bromoethane from ethene. And thirdly, to make ethanol from ethene, there's a little bit more credit available here. So we're going to add steam. So we need water or steam. If we're going to say water is what we add, then we need to show a high temperature, a temperature above 100 degrees to show that the water would actually be in the form of steam. So that's going to get us a mark. And then another mark for the acid catalyst that would make that happen. So far I make it 4 marks scored. So next we've got to name and describe the mechanism for the conversion of ethene into 1,2-dibromoethane. In other words, the first reaction. We've got to use curly arrows and we've got to include relevant dipoles, and it would be very easy, I think, to forget this. We've got to name that mechanism. So you may want to start with that or you may want to do it last, but then you do run the risk of forgetting that this mechanism is going to be electrophilic addition. So I've got that written down there. There's 1 mark for that. And then the mechanism itself, well, we need relevant dipoles on the bromine molecule. So because of repulsion by the pair of electrons in the carbon-carbon double bond, the pair of electrons in the bromine to bromine bond is repelled towards this bromine atom. So this is our delta minus bromine, this is our delta plus. Our first mark on the mechanism is for a curly arrow from the middle of the double bond on the carbon-carbon part to the delta positive bromine. The second mark is for the dipole being shown and the curly arrow breaking that bromine-bromine bond and forming a bromide ion. The third mark is to show the intermediate. So one of the 2 carbons has now got the bromine atom attached, the other carbon is a carbocation, a positive carbon ion. Full positive, not delta positive. When we broke this bond, we formed a bromide ion, Br- with a lone pair. And the last mark is for the curly arrow, showing that lone pair of electrons attacking the positive carbon and forming the second carbon to bromine bond, 1,2-dibromoethane. So that should add up to 9 marks. 4 for the mechanism, 1 for the name of the mechanism makes 5. And then the 4 marks that we had earlier for the first part of the question. And that's it for question 1.